Hi there, this is our last lesson video on sequences. It's a bit of a revision of exam questions, followed by the mixed practice as well for this chapter. So remember the last time we saw the formulae for APs and GPs, but there's more than just that. There's also the potential for questions being written as iterative sequences, and also you seeing this sigma notation, which we've got a calculator button. But sometimes it's useful, sometimes it's not, and I suppose we'll see examples in a bit when it can be used and when it can't. So I've got a question for us straight away. It says geometric at the top. Do I agree with that? U1 is 15. Well, of course, that means A is 15. And then UM plus 1 is, well, actually, this is written iteratively. It's given me a formula where it says the last term equals, so the next term equals 0.8 times the last term. So that's an iterative sequence. But of course, if I'm timesing by 0.8 every time, that makes it geometric. So here my R will be 0.8. So if I get on my calculator, it says write down the values of U2 and U3, etc. So if I type in 15 equals, and then I can just go times by 0.8, and that gives me U2. I've got U2 is 12, and the reason why I could have done that in my head, but just doing this in the calculator, press equals, and my next one is 9.6, so U3 is 9.6, and then U4, press equals again, what's that, 7.68. Okay, so this next part, well, it's got this summation notation. What you need to see here is, because it goes from 1 to 20, of all the nth terms, that is really just saying find me please S20. It's quite an old question this, so I think it should be quite a gentle question. Certainly the newer ones are a bit harder. And there's also question 1 on the exam, so again another reason why it's quite a gentle question. So anyway, it wants S20. We've got this formula down here, that's what I'm going to use. So I'm going to use A 1 minus R to the n over 1 minus R. So what's the A? The A is 15. Times by 1 minus A, which is 0.8, to the power n, which was 20, all divided by 1 minus 0.8. So that is just put it in the calculator using the fraction button. So it's 15 times by bracket 1 minus 0.8 to the power of 20. Close the bracket, divided by that. And I get 74 and a bit. Now, it's usually non-exact answers, you normally round to 3 sig figs. So I'm going to call it 74.1. 12, yeah, and that's what they've got. Yeah, exactly right, 74.1. So happy with the first question. The second question, now this is a much more recent question. So this is June 19. It's the middle of the exam, question 7, so I expect this to be a bit harder. A sequence is defined by un equals... Now, first thing I'm noticing, there's no un plus 1s or anything. So this is a proper formula, if you like, an nth term formula. And it's a bit weird again. I suppose I just need to work out what they are. U1 is 25 times 0.6 to the n, which if you do it, and that the answer is 15. It's 3/5 of 25, and then you have to do it again. 25 times by the 0.6. Every time you times by the 0.6. Again, I get 9 now. So U2 would be 9. So I reckon then A is 15 really. It looks like it should be 25, but it's not really. And R is the 0.6. Okay, so now I've sussed this. What it actually says, use an algebraic method to find the smallest value of n such that this is true. All right then, fair enough. Now, first of all, again, notice what this wants you to do. This is actually the sum to infinity. And this is the sum to n terms. So we're really doing that, S infinity minus Sn. Okay, S infinity is A over 1 minus R. So that's A, what was A? A was 15 over 1 minus R. Now I can just write 0.4 for that, because 1 minus 0.6. Minus, now interestingly, it's got the same thing. It's A over 1 minus R times by this extra thing. So I'm going to get the 15 over 0.4 again, but I'm going to get this additional bracket which says 1 minus 0.6 to the power of n. And it says that there's got to be less than, well, this, think of this as 0.0001. So it's probably easier just to write that. Now I can take out this 15 over 0.4 as a common factor. If you do 15 divided by 0.4, you get 37.5. So I'm going to do that. I'm going to take that out as a common factor. I get it goes once into that minus that. So that when I do that, they don't go. They just sort of factorize. And I get 1 minus 0.6 to the n is less than 0.0001. And notice in this bracket, 1 minus 1 kind of disappears. And minus is 0.6 to the n. So I'm happy with that. That's just 0.6 to the n. And I'm going to move the 37.5 over. And that's that divided by it. So it's 0.0001 divided by 37.5. Okay. So it's 1 over 375,000. Now this is whenever you get a power, is the thing you're after, you take log. So I'll take log of this, and I'm going to move the n to the front. Is less than log of 1 over 375,000. And when I divide by the log of 0.6, I know the log of 0.6 is negative. I'll just do it on the calculator. Yeah. So what that does is it changes the sign. It's the log of that divided by the log of 0.6. Let's just do that sum. It's the log of 1 divided by 375,000, and then divided by the log of 0.6. I get 25 in a bit. So I've got n is greater than 25. Now it says the smallest value. So I'm going to guess that n is 26, one more than it. N is 26, there you go. Now, next question. It's an arithmetic one. It's quite an older question again, so it's our first one. So let's have a go. The 10th term of an arithmetic progression is equal to twice the 4th term. So the 10th term. The best way of writing that is U10 equals twice U4. And it says the 20th term is 44. So U20 is 44. So we've got some information here, but I think this is almost simultaneous equations. So let's start off. U10 is A plus 9D. And that, it says, equals 2 lots of U4. So it's 2 lots of A plus 3D. Notice I always take away 1 because that's what the formula says. It says n minus 1d. So that's that written out there. I can just tie that up a bit. A plus 9d equals 2a plus 6d. Move the a that way and the d's that way. I reckon 3d is a, or a is 3d. That will be useful in a bit. Now if I come over here, U20 it says is 44, and of course that's a plus 19d is 44. But I know that a is 3d. And that clearly gives me 22d. And therefore d is 2. And because I know d is 2, 3d is a. So a must be 6. That worked out quite nicely, just simultaneous equations. Find the sum of the first 50 terms, simply a case of just chucking it into this formula. It's 50, I'm going to use this version of it here. It's a half of n. 2a, what was a? A was 6, so that's 12, plus, it says n minus 1, so that's 49, times the d, which was 2. So it's 25. 49 times 2 is 98. 100 times, that's 110, I reckon. So I think it's just 25 times 110, which is 2750. There's my answers. What have I got? 6 and 2, I agree with that, and 2750, I agree with that. An iterative sequence, we saw a bit one earlier on, but again, quite an old question. U1 is 8, n plus 1, the next term is the old term plus 3. Oh, right, this is a relatively straightforward one, because you're just adding on 3 each time. So it will go 8, then it'll go 11, then it's 14. So even though it's iterative, it's really arithmetic because you're adding on the same amount each time. So I think we saw this question actually previously. I'm not sure if we did it all. The nth term can be written in the form un pn plus q. So I think it's un equals so it goes up in 3, so it's 3n plus 5. There you go. And it's an arithmetic sequence. And the very last thing, it says find the sum of these. Now, of course, we've just seen the formula for the Sn. It's a half of n, 2a plus n minus 1d. That's the nth term. Now, what you need to see here is it actually wants me to go, well, this is Sn here. And this is actually S of 2n. This is going up twice as far. So I need to put 2n into this for this first one, and then I need to put n into it and take them away. So if I do that over here, S of 2n will be a half of 2n. 2a, what was a? A is 8, so that's 16 plus. Now it says in the formula n minus 1, so it's obviously 2n minus 1 times d, and it goes up in 3s. I can tidy that up. Half of 2n becomes n. I've got 16 plus, this is 6n minus 3. So I reckon that's n 13 plus 6n. I can obviously tie that up a bit more. S of n, this one, this is simply a half of n. 2a is 16 again, plus n minus 1 times by the 3. You can see I'm going to do the same trick. It's a half of n this time though, because I can't get rid of the 2's. 16 minus 3 is 13 plus 3n. Minus 3. Yeah, I think everything else is right there. And I've got to do this minus this equals that. So let's try that. N 13 plus 6n minus this, half n 13 plus 3n equals 1256. It's not a particularly nice equation. Tidy it up a bit, I can get 13n plus 6n squared minus half of that is minus 6.5n plus, no, minus, sorry, nearly made a bad mistake, 1.5n equals 1256. So it's a quadratic equation. I'm going to tidy it up and write it there. So I've quickly tidied it up. Actually, I realised I made a mistake as well. That should have been a squared. But other than that, that's in my equation. And when I typed that in, I've just typed it in just now, n equals 16 when you solve this equation. Press equals again, and I've got a negative answer, which presumably we can't have a negative number of n. So I think n should be 16. Oh, I haven't even got the answer on that, so obviously I didn't go as far as that. Oh, there it is, n is 16. I've got a chance just to quickly do this one. In a geometric progression, the sum to infinity is 4 times the first term. So again, if I'm doing this, I'm thinking my sum to infinity is a over 1 minus r, and it's 4 times the first term. There you go, 4a. All right, this looks like then an equation, because a's cancel on both sides, you see, that's the trick here, and therefore 1 over the 1 minus r is 4. Put a different way, 1 over 4 is 1 minus r, because they switch, and therefore r is 3/4. I'm happy with that. The third term it says is 9, so that's ar squared, it's geometric, is 9. So a times by 3/4 squared is 9, and presumably I do 9, and you want 9 divided by 0.75 squared, and it just says 16. So a equals 16. And the last thing it says, find the sum of the first 20 terms. So that's a over, well, bear with me 2 seconds. So I've quickly rewritten all that in. If I type it into my calculator, or if you type it into a calculator, you should then get 16 and 63.8. So see if you can get that as your answers. This is what I'm after you doing. The mixed practice 4. Nice bunch of examples of what you need to be able to do to solve these exam questions. So best of luck.